Hey guys, Dr. K here again. Do you like to know how to solve a kinematics problem, a motion related problem very easily without using kinematic equations? I'll show you a problem. There's a problem related to motion, and you can solve it without using kinematic equations. So, let's take a look at that type of a problem. Okay, so this is the problem. I have a slope. This is a inclined plane that is frictionless, so there's no friction here. It's 10 meters long. This is 30 degrees. It makes an angle with the horizontal 30 degrees. That's the gravitational acceleration, and there's a mass m that slides down this slope. It's going to start from rest, meaning its initial velocity is 0. We need to find the final velocity when it hits the ground level. When it comes to the ground level, what is its speed? So that's the problem. Usually you can use kinematic equations to solve this problem, but I'm going to show you a much more easier way of solving these problems, these types of problems. So what we are going to do is that we are going to compare the mechanical energy of the system over here when the object is over here, and the mechanical energy of the system when the object is over there. And mechanical energy, if there are no resistive forces, if there are no external forces acting on the system, the mechanical energy is conserved. So let's call this point A, this point B. Mechanical energy is conserved at point A and point B. Okay, conservation of mechanical energy. So what's the mechanical energy of the system over here? Can you see, like, it's at rest, so there's no kinetic energy. Over here, it's completely gravitational potential energy. It's completely gravitational potential energy. So I'm going to write down for this side, kinetic energy is 0 plus there's potential energy due to gravity at point A. That's mechanical energy at point A. And over here, when the object slides to the bottom of the ramp, like it's not stopping at that point, it's like still moving. Okay, so there's kinetic energy over there, but it has reached the bottom of this slope. So what we do for convenience, we are going to consider this bottom of the slope to be our potential energy 0 level. It's our reference level. So we are going to assume that the system's potential energy due to gravity when the object reaches this level is 0. Okay? It's 0. So when the object reaches this point, the system has no gravitational potential energy, but it has kinetic energy. Okay, so I'm going to write down mechanical energy at point B as kinetic energy at point B plus potential energy is 0. Potential energy of our system is 0. And I need to tell you one thing that I forgot to tell you. What is our system here? I'm talking about a system. What is our system here? The system is this sliding mass, the mass that is sliding m plus the earth. M plus the earth. That's our system. Okay, so what we are doing is we are comparing the mechanical energy of the system when the mass is at this point and mechanical energy of our system when the mass is at this point. And that level we consider as the potential energy due to gravity 0 level. Okay, so now look what we have. We have potential energy due to gravity at A equals kinetic energy at B. Okay, this is very simple, but yet it's very powerful. How do we write the potential energy due to gravity? mgh, mass of the object, gravitational acceleration, times h. What is h? H is the vertical separation. H is the vertical separation. So from the reference level to the position of the object. Okay, so this is trigonometry. Look, you have a right angle triangle here, hypotenuse 10, the angle is 30, we need this side. Look, 30 is opposite to this side, so we are looking for the opposite side. Always remember, if it's opposite, then it's sine. Okay, then it's sine. So how do we find this side? 10 sine 30. Sine 30 is 0.5, so 10.5 is 5 meters. It's 5 meters, guys. So here you should put the answer 5. mgh equals kinetic energy. Do you know the expression for kinetic energy? 1/2 mass times speed squared. 1/2 mass m, because they haven't given us a specific value for the mass, so I'm just going to consider it as m, times v squared. So v, velocity, I'm just looking at the magnitude of that speed, this value squared. So v final squared. And that's, we are almost there, guys. Okay, now look, m and m cancels out. Can you see there's a m on both sides? They cancel out. I told you what we need is v final, right? I'm going to solve for v final. So v final squared. Look, there's a 1/2 here. I'm going to multiply this by 2. So then I need to multiply this side by 2 as well. So 2 times 5 is 10. 10g. 10g. And then I'm going to take the square root on both sides. Look how I'm going to take the square root on both sides. That's how you do that. So then here it's going to be v final equals square root of 10 times g. What is g? What is g? G is 9.8, guys. Okay, so 10 times 9.8. So v final is square root 98. Okay, square root of 100 is what? 10. 10. So this is very close to 10, but slightly lower than 10. It's actually 9.9. So v final is going to be 9.9 meters per second. Meters per second. So that's the speed of the object when it's at that point. Its direction, if you're thinking about the velocity, the direction is like that. Okay, so at that moment it has a speed 9.9 meters per second in this direction. In this direction, it's sliding downward. So that's how you do this. So instead of using kinematic equations, you can use energy, conservation of mechanical energy, to solve certain types of motion problems. So another powerful technique that you should know when you are dealing with motion related problems. Okay, physics motion related problems. Okay guys, I'll see you in another video. Have a great day. Follow me on TikTok. Bye for now.